why light is not moving through space. What I found will break your reality. Ladies and gentlemen, I want to begin with something very simple, something so obvious that you've never questioned it. When you turn on a flashlight, you say, light comes out and travels across the room. Seems reasonable, right? But here's the problem. That sentence may be completely wrong. Not a little wrong. Not technically wrong. Fundamentally wrong. Let me ask you something. When you throw a ball, it moves from your hand to the wall. You can track it. You can measure its position at every moment. Now imagine doing the same thing with light. You say, well, light leaves the bulb, travels through space, and hits my eyes. But how do you know it traveled? What you actually observe is this. The bulb is on, and then your eye detects light. Two events, not a journey. Now here's where things start to get strange. We know the speed of light is constant, always the same, no matter how fast you're moving. That alone is already bizarre. But it gets worse. If you take the equation seriously, and I mean really seriously, you discover something unsettling. For light itself, time doesn't pass. Think about that. From the point of view of light, and I put that in quotes because it's already a dangerous idea, the moment it is emitted and the moment it is absorbed are the same moment. No time in between, no journey, no travel. So what does it even mean to say light moves? Moves through what? Through space. Well, space is something we use to describe relationships between objects, distances, positions. But if there is no time passing for light, then there is no meaningful distance being experienced. It's as if the entire idea of motion breaks down, not gradually, but completely. Now let's push this a little further. In quantum physics, light behaves like a particle and like a wave, and sometimes like neither. You can't say it took one path or another. In fact, until you measure it, it doesn't even decide. So how can something travel if it doesn't even have a definite path? We like to imagine photons as tiny bullets flying through space, but that's just a story we tell ourselves because it's comfortable. Reality doesn't care about our comfort. Here's a different way to think about it. Instead of imagining light as something moving, imagine it as a connection between two events, an emission event and an absorption event, not a thing that exists in between, but a relationship that ties them together. Now, I know what you're thinking. That sounds abstract. That sounds philosophical. Good, because physics, when you push it far enough, always becomes philosophical. Not because we want it to, but because reality itself refuses to fit inside simple boxes. Let me give you an analogy. Imagine a movie. You see a character walking across the screen. But what's really happening? A sequence of still frames. There is no actual motion inside any single frame. The motion exists in the way the frames are connected. Light might be something like that. Not an object moving through space, but part of a deeper structure that connects events across the universe. And if that's true, then the idea that light travels through space is just a convenient illusion. A story we tell because our brains are built to understand motion, distance, and time. But nature? Nature doesn't have to follow those intuitions. Now here's the part that really breaks your reality. If light is not truly moving in the way we think, then space itself might not be what we think it is either, because we define space using light. Distances are measured by how long light takes to go from one place to another, but if that taking time is not fundamental, then space may not be fundamental either. You begin to see the problem. Pull on one thread, and the whole fabric starts to unravel. So where does that leave us? It leaves us with a very uncomfortable truth. The world we experience, the solid, continuous, intuitive world, is not the real story. It's an approximation, a useful one, but still an illusion. And science, at its best, is not about giving you comfort. It's about taking away illusions, even the ones you didn't know you had. So the next time you see a beam of light cutting through the darkness, don't just think of it as something moving. Think of it as something deeper, something stranger, something that doesn't quite fit into the idea of motion at all. Because the truth is, light isn't just illuminating the world around you, it's exposing the limits of how you understand reality itself. The first thing we have to confront is something that feels almost insulting in its simplicity. The idea that light moves might be nothing more than a story we've told ourselves because it fits our everyday experience. When you watch a car drive down a road or a ball fly through the air, you are seeing continuous motion, something occupying positions in space over time. Naturally, you extend that same intuition to light. You imagine it leaving a source, crossing space, and arriving somewhere else. But this is where the trap begins, because you are borrowing logic from objects that have mass and applying it to something that does not behave like an object at all. What you actually observe, if you strip the situation down to its bare essentials, is not motion, but two separate events: emission and detection. A light source turns on, and later your eye or a detector registers that light. Everything in between, the idea of a tiny thing traveling through empty space, is something your mind fills in automatically. It feels obvious, almost unavoidable, but that does not make it true. Physics has a long history of showing us that what feels obvious is often the first thing that must be questioned. Now, here is where it becomes deeply unsettling. When we analyze light using the most successful theories we have, we find that the concept of a continuous journey becomes harder and harder to justify. Light does not leave behind a trail you can follow. It does not have a well-defined position at every moment in the way a moving object does. Instead, it behaves in ways that suggest the in-between might not exist in any meaningful sense. The motion you imagine could simply be a reconstruction your brain creates to make sense of two disconnected points in time. So the illusion of motion is not a small misunderstanding, it's a fundamental misinterpretation of what's happening. We are so accustomed to thinking in terms of paths and trajectories that we impose them even where they may not belong. And once you start to doubt that assumption, you begin to realize that what you thought was a journey through space might actually be something far more abstract, something that challenges the very idea of motion itself. The second idea pushes us even further away from common sense because it forces us to question not just motion, but time itself. We are used to thinking of time as something universal, something that flows the same way for everything. A second is a second, whether it's for you, for a moving car, or for a beam of light. At least that's what intuition tells you. But nature does not agree with that intuition, and this is where things begin to fall apart in a very dramatic way. When we carefully examine the behavior of light using the framework of special relativity, we discover a strange and uncomfortable fact. The speed of light is always the same, no matter how fast you are moving. You can chase a beam of light at enormous speed, and it will still move away from you at exactly the same speed. This is not just surprising, it is deeply disruptive because it forces space and time themselves to adjust in order to keep that speed constant. And when you follow this logic all the way to its extreme conclusion, something extraordinary happens. The equations tell you that as something moves faster and faster, time for that thing slows down relative to an outside observer. Push this idea to the limit, right up to the speed of light, and time doesn't just slow down, it stops completely. Now pause and think about what that means. If time does not pass for light, then from its perspective, and again, that word is already stretching things, the moment it is emitted and the moment it is absorbed are not separated by any duration at all. There is no waiting, no traveling, no passage from one point to another. It is as if the beginning and the end are the same instant. This creates a paradox in our everyday language. We say light moves, but movement requires time. If there is no time, what exactly is moving? The concept begins to collapse under its own weight. What we thought was a journey across space becomes something more like an instantaneous connection between two events. And this is where reality starts to feel unfamiliar. Because the deeper truth may be that light does not experience the universe as a sequence unfolding over time. Instead, it links distant points in a way that bypasses the very notion of duration. The trip from a distant star to your eye, which might take millions of years from your perspective, could, at the most fundamental level, be no trip at all. The third idea challenges something even more deeply rooted in our thinking: the assumption that space is like a stage, a kind of invisible container through which things move. We imagine space as something empty but still there, waiting for objects and light to pass through it, the way water allows waves to ripple across its surface. It feels natural to ask, what is light moving through? As if there must be some medium, some background, some substance that makes motion possible. But this intuition turns out to be misleading. In the past, scientists actually believed in something called the ether, an invisible substance that was supposed to fill all of space and carry light waves. It sounded reasonable at the time because every wave we are familiar with, sound waves, water waves, needs a medium. But experiments kept failing to detect this ether, no matter how carefully they looked. Eventually, the idea had to be abandoned, not because it was inconvenient, but because nature simply refused to cooperate with it.